Swayam Prabha. Digital India. Educated India.
Welcome to the course on Organic Chemistry 2. In the first module, we will be studying about preparations of alkyl halides. The first lecture will be preparation of alkyl halides from alcohols. I am Dr. Balaji, currently working as Associate Professor in the School of Biotechnology at Jawaharlal Nehru University. This project was sponsored by DTH Swayam Prabha, MHRD, New Delhi. The topics that we will be covering in this particular session include preparation of general methods of alkyl halides, and mainly we will start from the alcohol methods. The first one is Gru's method, where we employ HCl and zinc chloride. The next one is using PCl5 or PCl3. It will be followed by Darshan's method using thionyl chloride. Let us look at preparation of alkyl halides. So in this session, we will be looking at what are the different methods of alkyl halides preparation. So the first method is from alcohol. This is by the substitution of the hydroxyl group by the halogen. The next one is from alkanes. In the case of alkanes, that is basically hydrocarbons, we have radical reactions which can be used to make alkyl halides. And the next one is alkenes. Alkenes actually undergo addition reaction. Basically, electrophilic addition reaction is one of the reaction by which alkyl halides can be prepared from alkenes. We have two different types of alkyl halide preparations. The first one is from a HX, that is a reagent which is used for the formation of hydrogen alkyl halide is hydrogen halides. The next one is the reaction with halogens, X2. Afterwards, we will study about the reactions of halide exchange reaction, that is chlorides or bromides can be exchanged with iodide. So this kind of reaction, the name reaction is Finkelstein reaction. We will study about this reaction also. The next one is from the Hunsticker reaction, or the silver salts of carboxylic acids can be converted to alkyl halides. Then allylic halogenation is the next reaction we will be studying. In this allylic halogenation reaction, we will be using basically N-bromosuccinimide as the reagent for the allylic bromination. And the last one is the haloform reactions. For the haloform reactions, the substrate has to have a methyl group. It can be either acetaldehyde or acetyl ketones can be converted into haloforms by this particular reaction. So these are all the various reactions of alkyl halide preparation. Okay, let us look at the synthesis of alkyl halides from alcohols. So this is the first method which we are going to study now. So the method is called as a Gru's process. In this particular process, the reagent used is basically hydrogen chloride, hydrochloric acid, and the zinc chloride, which is a Lewis acid. The substrate is basically primary or secondary alcohols. So this reaction is applicable for the synthesis of alkyl halides from primary or secondary alcohols. Let us look at how the reaction actually proceeds. So in the first step, the alcohol and the HX are heated to give the alkyl halide and water. We will look at the role of the zinc chloride, which is a Lewis acid. So this is very crucial for the success of this particular reaction. So the alcohol is having lone pair of electrons. This is the Lewis acid. So that means this is electron rich and this is electron deficient. So the lone pair donates, the oxygen's lone pair is donated to the zinc, and here we will see the oxygen becomes positive charge because of the donation of the electron towards zinc, and the zinc gets the negative charge. So from this the RO bond is broken to produce the alkyl cations or the carbocation, and the hydroxy group is attached to the zinc chloride, and this reaction is mainly applicable for primary or secondary alcohols. And this alkyl carbocation reacts with HX to produce the alkyl halides. So this is H plus and X minus. The halogen is having a negative charge. So this X minus and R plus join together to give the RX compound. And here you can see how the electrons are shifted from the lone pair of oxygen's lone pair is shifted to the zinc atom. And we also have another case of tertiary alcohols. In the case of tertiary alcohols, we don't need to use the zinc chloride. The zinc chloride is not required because the carbocation can be easily formed. When the HX, the H plus adds to the OH group, it forms the H2O plus group, which is a good leaving group, and this results in the formation of a tertiary carbocation. Since the tertiary carbocation is quite stable, this reaction does not require the zinc chloride, and the Cl minus from the reaction can attack this carbocation to form the final alkyl halide. So this is another method. So from alcohols, the Gru's process can be used to make alkyl halides. Let us look at another method of preparation of alkyl halides from alcohols. In the previous one we saw HX and zinc chloride reacts with alcohols to produce the alkyl halides. In this particular one we will be looking at the phosphorus derivatives, mainly PCl5 and PCl3. These are all the two reagents which can be used for the preparation of alkyl halides. So the substrates involved are primary, secondary and tertiary alcohols. So the alcohol reacts with the PCl5 to give the alkyl halide and hydrochloric gas and POCl3. So three molecules of alkyl halides, alcohol reacts with the PCl3 to give three molecules of alkyl halides, and H3PO3 acid is formed in that reaction. And in the case of iodine, we don't have to use PI5 or PI3 because they are highly reactive substances. So phosphorus and iodine can be used to produce the reactive species, and the alcohol reacts with this combination to produce the alkyl iodide. One of the limitations for this particular reaction is, in the case of straight chain primary alcohols, the PCl3 reaction does not give any rearrangement, but in the case of secondary alcohols, PCl3 reaction actually gives rearrangement. So this is one of the limitations of use of phosphorus trihalides for the preparation of alkyl halides. To overcome this problem, people generally use thionyl chloride. We will look at this Darson's method later. So alcohol reacts with the thionyl chloride to give alkyl halide, and HCl and SO2 is formed. So in this case, HCl and SO2 are the gases, so they escape very quickly from the reaction medium. So this reaction gives very high yield of alkyl halides. We now saw the preparation of alkyl iodides from the alcohols. Here the stoichiometric reaction is written with a completely balanced equation. So 6 molecules of the alcohol reacts with 2 phosphorus molecules and 3 iodine to produce 6 alkyl iodide plus 2 H3PO3. So this is the balanced reaction for this preparation of alkyl iodides. And as I mentioned a little bit earlier, In the reaction of alcohols with thionyl chloride, that is the Darson's method, the sulfur dioxide and HCl are the gas which escapes from the reaction medium. So this reaction is giving high yield of alkyl halides. Let us recap the summary. We had seen the preparations of alkyl halides from alcohols, mainly primary, secondary and tertiary alcohols. We had seen Grew's process where we employ HCl and zinc chloride. The zinc chloride used is a Lewis acid, and this method, the use of zinc chloride is preferred for the preparation of primary and secondary alkyl halides. Tertiary alcohols does not require this catalyst, and it is followed by the synthesis of alkyl halides from alcohols using either PCl5 or PCl3. Then we also see the method of preparing alkyl halides using thionyl chloride, because there were some limitations when we use PCl3 and PCl5 methods. So to avoid that, we are using Darson's method for the preparation of thionyl chloride. So with this, we conclude this particular session on the preparation of alkyl halides used from alcohols.